Like logarithms, provided that when we plug it in, it exists. If we plug the number into a rational function, we get a value back, then the limit must be equal to that value. Okay, we're going to take a look at a graph and see why. But if f of c exists, then the limit exists. So we can just plug it in and figure out, well, whatever we get back is the limit. We're going to start out with f of x equals 1 over x, perhaps the most basic of rational functions. It's rational because the variable's in the denominator. So let's just say we want to figure out the limit as x approaches 2. Well, we can see that the y value is 1/2. We can see the limit must be the same. Now, there is an asymptote here at 0, but provided that we get a value back, we can see that it's continuous everywhere except where these asymptotes exist. So provided we get a value back, that means that's going to be our limit value. And this is the case for most functions. So let's say we want to find the limit as x approaches 1. Well, the y value is 1, but so is what it's approaching, which is the limit. Same for -1. As it approaches -2, the y value approaches -1/2. We can randomize this and make different rational functions. Some of these are quite crazy looking. But we can see that wherever the y value exists, the limit's going to be the same. And as you drag the point more, you'll see that this works. And so for rational functions, the same thing holds. Provided you plug it in and you get something back, the limit as x approaches c of f of x is going to be the same as the function value at c. Again, this goes under the umbrella of all of these following functions: rational, logarithmic, polynomial, exponential, and what we're about to look at, which is trigonometric. If you plug it in and you get something back, then guess what? The limit is going to be equal to the function value. Let's take a look at a few examples of that. Let's say you have f of x equals x squared plus 2 over 4x minus 1, and you want to figure out the limit as x approaches 0. Well, guess what? Let's just plug in 0 into the function. So f of 0 equals x squared plus, oh, whoops, I meant to plug in 0. Let's try this again. So 0 squared plus 2 over 4 times 0 minus 1. That's going to be equal to 2 over -1 equals -2. Guess what? We got something back. It didn't get an undefined. So as long as you get something back, that's going to be your limit value. So that means the limit as x approaches 0 of f of x equals -2. So again, for any rational function that works, if you plug in a number and you get something back, that's going to be your limit value. Now, when you don't get something back, there's other rules that I will teach you that will give you the limit. So if you get like an undefined or a 0 over 0, we can learn how to do that in another lesson. But as long as you get a regular number back, that will be your limit value. If you have any other questions about rational functions, let me know.